Good morning, student. Today we will discuss the topic factor affecting the resistance of a conductor. Resistance, you already know, means which resists the flow of charge or current. Conductor, which allowed to pass electric current, and conductor, which is good in nature, their resistance is negligible. Where the conductor has appreciable some amount of resistance, that conductor is known as resistance. But and the material or the substance which does not allow to pass the current, means resist the flow of current, we will not say the completely insulator, means they are poor conductor. If they completely resist the flow of current, it means they are insulator. Means what are the factors which affect the resistance of a conductor, means wire. To explain what are the factors affecting the resistance of a wire, we will go through the activity. Here is the activity and we will check the experiment. And for this we have to take some component, and you know what is this? Identify. And this is switch, and here is dot, switch is open or closed. This is ammeter connected in series, and this is cell of any voltage, and these are connected with the help of conductor, mean wire. Here we have left some gap, two ends, one is X and other is Y. Why we have filled the gap and leave the gap? To identify, means on which the factor, on which condition the resistance will depend. First we will take a nichrome wire, and nichrome, you know it very well, is an alloy of nickel, chromium, manganese and iron metal. First case, we will take a nichrome wire of length L, and this nichrome wire XY is placed at here. This XY is the nichrome wire whose length is L, which make the circuit complete, because switch is already closed, mean allowed to pass the current. When the current will pass, it's show the reading in ammeter. Then reading will increase or decrease, that will be confirmed. Means if this L will place XY, then it shows the some reading. Reading on ammeter is indicate the amount of current, which is I. Then we are assuming that this I is the current when we place a nichrome wire of length L. First case. Second case, if we put the second wire of length 2L, double of it, this represent also in this way, means this is 2L, this is 2L, here is length is double. Then it again show the amount of current, and what is the amount of current? That is I1. And the third case, if you put a thick wire of the same length L, but the thick wire is comparatively thick, means more diameter than this one. This third condition, it is the third condition, means thick wire of length L is placed between X and Y, and the circuit will complete. Then we note down the amount of current, I2. Here are the three conditions of current I1 and I2. Now, this conductor means wire having some property to resist the flow of current or flow of charge, and which represent R. It means when we first case, when we put L length, the current is I, and we know I R is proportional to 1 upon I, or I is proportional to 1 upon R. First case, when we put the wire of length L, it indicates some current, and that current we are assuming I, and we don't know the resistance. And second case, if the length is double, then I will be length will be double. If length double, then I will be half. जब length बढ़ा दी जाएगी, when the length will increase, then current will decrease. Why current will decrease? It means first condition is there, resistance is depend upon length. It means resistance is directly proportional to length. It means if length is increased, then resistance will increase. If resistance will increase, current will decrease. We know the current is directly proportional to the resistance. If length is increased, resistance will increase, and if the resistance will increase, the current will decrease. This is the first condition. It means the resistance is directly proportional to L. This is the first condition. Means when length increase, resistance will also increase, but current will decrease. This is the first condition. Second, R, where third case, we take a thick wire. Resistance is inversely proportional to area. If the wire is thick means diameter will more. If the wire is thick, then resistance will less. If the resistance will less, then current will be more. It means we have to use always thick wire. Why? Because in thick wire, resistance of the current is less, and less resistance means allowed to pass the electric current. Means more current will produce. Thick wire have less resistance means help to produce, has more current. And the third is, it depends upon the nature of material. What is the type of nature? Nature of material mean conductivity, mean good conductor, poor conductor, or resistance. Third is temperature. Means difference of the temperature will change the resistance of a wire. These are the four factors on which the resistance of a wire is dependent. Mean first, according to numerically, we have to know first length of the wire, means depend upon the length of wire. First is resistance is directly proportional. Resistance is directly proportional to L. Resistance is inversely proportional to area. First and second. Third, nature of material. Fourth, temperature. These are the factors on which the resistance of a wire depend. It means more length, more resistance. And I, please, I is equal to 1 upon R, means we can say proportional to, sorry. More length, more resistance mean more current. It means R is more when length is more. Example, I is proportional to 1 upon L. More length, current will less. It means we have to use less length from supply. Second, if the area will more, then resistance is less. If the resistance is less, current will more. It means I is proportional to 1 upon A, and this A will be in upward, means I is proportional to area. It means more area, more current. More length, less current. Why? More length, resistance more, current less. If area is more, resistance is less, current will more. And directly we can easily answer the question, if the length of the wire is more, then current will be less. Why? Because resistance is more. If the wire is thick, more area, then current will more. More area means resistance less means current will more. Or we can put out the result, more length, less resistance, and more area, or vice versa. Area, more length, less current, and more area, more current. Please keep it in mind. More length, less current, more length, less current, less length, more current. Reciprocal. More area, more current, less area, less current. Same again, more length, more resistance means less current. More length, less current. More area, less resistance, more current. More area, more current. Less area, less current. And combine these combining equation. 1 and 2. R inversely proportional L upon A. R is equal to, this is the rho, L upon A, this is rho, and this is the resistivity. This is rho, this is resistivity. And the unit of resistivity, its symbol is rho. Symbol is rho. R-H-O, its symbol is rho. And now, what is the resistivity? Here is R is equal to resistivity L upon A, then cross multiply R into A is equal to rho L. Cross multiply R into A, cross rho into L. This is rho and this is L. And that means R A upon L is equal to rho. So unit of rho, unit of resistivity is R is the resistance, ohm, area meter square upon meter will cut, ohm, meter means omega m. And now listen carefully. What is the resistivity? Resistivity is the property of a material which has the offer the resistance through a length of 1 unit and having the cross sectional area 1 unit square is known as resistivity. Or another way you can define the resistivity. The resistivity, listen carefully. The resistivity is the resistance offered by wire of unit length through having a cross sectional area 1 unit square. Again listen carefully. Resistivity is the resistance offered by a wire of unit length through a unit cross sectional area. Unit cross sectional area is known as resistivity. What is the resistivity means? Resistivity is the resistance which is offered by a wire which has the length of 1 unit and cross sectional area is 1 meter square. This is the wire which has cross sectional area is 1 unit square and the length is 1 unit. It means the resistance of that wire is the resistivity, which has the length is 1 unit and area is 1 unit square. Cross sectional area. This is the cross section. When we cut this wire and the visible cross section will be the cross section area. This is the resistivity. This wire which has the length is 1 meter and area is cross sectional area is 1 meter square. 1 unit square is known as resistivity. And the unit of resistivity is ohm meter. And how it is ohm meter? This one. If one will say define 1 ohm meter, then how you can define 1 ohm meter? Means when the resistance offered by a wire of 1 ohm of 1 unit length having the cross sectional area of 1 unit square is known as 1 ohm meter. And the resistivity of a pure metal is always less, and some alloy have the resistivity is also less, but the resistivity of alloy is comparatively high. Some alloy have the low resistivity, some exceptional, but the pure metal have low resistivity whereas alloy have high resistivity. And the poor conductor means which does not allow to pass the current, resist the maximum amount of current, they have the more resistivity. Poor conductor. The characteristics of the resistivity is depend upon the resistivity is mainly characteristics, the resistivity on which the alloy of the resistivity of an alloy is high. Why? Because they do not oxidize easily. They do not oxidize easily and they have high melting point. Why non-metal or why the resistivity of alloy are high? Because they allow to pass the electric current less as compared to metal. Therefore, non-metal have generally high resistivity. And we used filament as a alloy. Why? Because they have high resistivity, they do not oxidize easily, and they have high melting point. Therefore, in filament of bulb, we used tungsten metal because they have high resistivity and do not oxidize easily and have high melting point. And other metal like copper and aluminium, they are using to transmit the electric current, to supply the electric current. Is it clear? And and do this question. State Ohm's law. Define resistance and define its unit also. On what factors does resistance of a conductor depend? Do question page 200, 202, 209 from NCERT. And next we will see the resistance, how the resistance, two or more resistance combine to each other.